Class example 2.3.4. Write each expression in factored form. So we're still thinking about the expanding, which is multiplying, and then its opposite operation or inverse operation as being factoring, or in other words, dividing. Now we've done really good work with the greatest common factor so far. This one looks a little bit different. Although it does have a greatest common factor, it seems a little bit odd. So what I wanted just to remind us of is a little bit of this multiplication we've done before called the distributive property. Now that's when we're going to take two terms and we're going to multiply those two terms together. Now they can be anything you want. A monomial times a binomial times a binomial. You can put some trinomials in there. Let's just go with something nice and simple. Let's go with y plus 2 multiplied by maybe y plus 3. Okay, pretty simple. And what we're going to do is we're going to distribute. Now we already know that everything on the first set of brackets, or the first term, must be multiplied by everything in the second term. And so what we did is we broke apart the y and the plus 2. So we broke apart the y plus 2 here, and we distributed the y plus 3 to both terms, right? And then what we did is we took y times y and y times 3. That was y squared plus 3y. Then 2 times y and 2 times 3, we got 2y plus 6. And we can go ahead and collect those nice like terms in the middle, and we would got y squared plus 5y plus 6. Okay? This line looks awfully a lot like this one right here in question A. So it looks like I've got a 4 and I'm multiplying it by an x plus 5. And then I've also got a negative 3 and I'm also multiplying it by an x plus 5. So it's almost like that x plus 5 is the actual common factor to both of those two terms. So we know that factoring is the same thing as dividing. So I could take 4 multiplied by x plus 5. If I said x plus 5 was the common factor in between those two, I'm going to divide out an x plus 5. Okay. Now I see this whole term on the top of x plus 5 and the same term on the bottom. It's in a nice set of brackets on the bottom. And all I'm left with is that nice 4 going on. And I could do the same thing with that negative 3x. It's being right now multiplied by x plus 5. But if I said that I'm factoring it, it means I'm going to divide it out. And I see that I'm going to divide out the common factor, or the greatest common factor in this particular case. It's always the greatest common factor. I'm going to take out and divide the whole term. But we know that when we divide things, anything divided by itself is just going to cancel each other out. And we're left with the 3x left over. So in this particular case, I can see that I've got x plus 5 as my greatest common factor. Then I was left, and when I divided out that x plus 5, I was left with a 4 minus 3x left over. And you can see all of a sudden that looks like this line, doesn't it? So we were expanding this direction to get down to a polynomial. Now we are factoring this direction to get back into two separate factors. Then if I expand these both out, they should come to the same term. So let's try that. Let's multiply 4 times x plus 5 and negative 3 times x plus 5. I'm going to expand these out. So 4 times x, 4 times 5, negative 3x times x, and negative 3x times positive 5. And let's collect like terms. I'm going to go in descending order. Okay. Now what happens if I did this with the FOIL? What happens if I did this and expanded it a different way? 4 times x is 4x. X times negative 3 is negative 3x squared. I get a plus 20 and I get a minus 15x. Looks like it's the same thing. If I rewrite this in descending order, I get negative 3x squared minus 11x plus 20. So I can see that either way, the distributive property or by expanding out the actual two factors, we get the same polynomial at the end of the day. Question B, let's try and look for a greatest common factor first, and then we might use a little trick here, okay? So if I have a squared plus 8ab plus 2a plus 16b, what I'm trying to do first, as I always should start with, is can I find a greatest common factor? So let's look at the numbers. I have a 1, right, as the coefficient between or in front of a squared. I have an 8, I have a 2, and I have a 16. Well, my greatest common factor between all of those numbers happens to equal to 1. Not overly useful, okay? Then let's look at the letters. I've got an a squared, an ab, an a, and a b. Well, I've got a squared, a, and a, so that's good. But here I've got a b, and none of them have A's, not all of them have A's, and not all of them have B's, so there actually is no greatest common factor for the question B right now. That's unfortunate. But what we could do, okay, and I want you to remember we just expanded out both of these, this term 2 times, 2 different ways, this polynomial 2 different ways, and we ended up having 4 terms there. How did we get from 4 terms down into only 2 terms or 2 factors? What we're going to do is we're going to do factor by grouping this time. So factor by grouping is another method we can use when we can't find the greatest common factor. Okay, we have no greatest common factor for question B, so what we're going to do is we're going to break it apart. You get some choices here. Now, I'm going to go with just what's there for now, and then I can show you a separate method. What I'm going to do is I'm going to break this apart. Now, I'm going to say a squared plus 8ab actually has a greatest common factor. Now, I know we already said that this has got a 1 there, so it's not overly useful, but this has 2 a's and this has 1 a, so I could actually factor out 1a. Now, factoring means division, so I'm going to take my first term and divide out my greatest common factor. I'm going to get my second term, and I'm going to divide out my greatest common factor. And so I get a multiplied by a plus 8b. Okay, let's just try this again, but this time, let's try this again with our second term. Okay, and I'm actually just going to quickly change this. So now I've got plus, or in other words positive, 2a plus 16b. So let's look at 2a plus 16b. What's common in between those? I can definitely see both are even, so I can take out a 2. Okay. I only have 1a here, and I only have 1b here, so that's not overly helpful, but at least I found that there was a 2 that was common. So I can take 2a, which is my first term, divide out my greatest common factor. The 2's cancel each other out, and I'm left with an a. I can do positive 16b and divide out my greatest common factor, which is 2. I can see that that leaves me with 8b. And it's the same for both of those 2 terms. So we can actually rewrite this as saying a squared plus 8ab is actually a multiplied by a plus 8b. Then I could say that if I had a positive 2 and I multiplied that by a plus 8b, that would be the same thing as positive 2a plus 16b. And now all of a sudden, just like we saw in question A, we have a common factor, or a greatest common factor, that happens to be an a plus 8b. And according to the distributive property, it must mean that a plus 8b was distributed to whatever the terms that we actually broke apart in the first place. So let's pull them back together. And I get a plus 8b multiplied by a plus 2. And that is going to be equivalent to a squared plus 8ab plus 2a plus 16b. Now, you know me. I'm going to check by expanding it out. So let's see what happens if we expand these out and collect our like terms. What I want to get to is a squared plus 8ab plus 2a plus 16b. I have a plus 8b. I'm going to multiply that by a plus 2. I'm going to use the claw method this time. or FOIL. A times A is A squared. A times 2 is 2A. 8B times A is 8AB. And 8B times 2 is 16B. And I can see I got back to my original question. Okay, question C. 6x squared minus 9x minus 2x plus 3. Now, it seems quite convenient that it's in this order, and it always seems to work out in that order, but I wanted to show you with this question that you can actually rearrange the order. So I can see we're always starting to look for our greatest common factor. I have a 6, a -9, a -2, and a 3. One even number, here's a second even number, and some odds. It's not overly helpful, so no number that goes into all of them. The next I can see is my x's. I have an x squared, an x, and then nothing. So there is no greatest common factor. When that happens, and we've got 4 terms, we are going to go to factor by grouping. Okay, so I'm just going to keep the groups where they are right now. Notice here, this time I've put that grouping on the left side of the -2 there. And I'm just going to look at 6x squared minus 9x first. Now, I can see that 3 is going to be the common number and 1x is going to be the common factor there. 6 divided by 3 is 2, and x squared divided by x leaves me with a single x. I have -9 divided by 3 is a -3, and the x's cancel each other out. Okay, so I could rewrite this as 3x multiplied by 2x minus 3. I'm really darn close. I can see I've got a -2x plus 3. I need to get this to a positive 2x minus 3, so it's like I'm trying to change the signs. So I am going to look at these two, and I see there's no greatest common factor. But I need to change the signs. And we've done this quite a few times. When there's a multiplication sign in between, a negative sign in front of a set of brackets, it's like we're multiplying it by -1. Well, let's take that out. Let's take out a -1. And if I take -2x and I divide it by -1, that's perfect. I'm left with positive 2x. And if I take a 3x and I divide out a -1, that's cool. I'm left with a -3. And so really, I could rewrite this as -1 multiplied by 2x minus 3. And then all of a sudden, just like in question A and question B, I have a greatest common factor, or a common factor now. I get 2x minus 3. My distributive law says that it must have been distributed to 3x and -1 because it's going to both of those. So I get 3x minus 1 as my leftover. Now, instead of expanding in this question, I'm actually going to try rearranging those terms and see if I get down to the same 2 factors. Okay. So let's take, I don't know, let's leave the 6x squared where it is, but let's switch around everything else. I like squares in the front, that's why, descending order. I don't know, let's go with minus 2x this time, and then let's go with minus 9x, and then plus 3. So I'm just swapping those middle 2 terms. You could swap more than that if you wanted to. You could even go 6x squared, I don't know, maybe plus 3, and maybe 2x minus 9x, I don't know. I think that in our particular cases, let's just go with this guy. Okay, so I'm going to look in between, and it's like I'm covering up the -9x plus 3, and instead I'm only looking at 6x squared minus 2x. I can see they're both even, and they both have an x in them, so I'm left with the 3x minus 1 left over. That's kind of interesting, so I'm going to write 2x multiplied by 3x minus 1. Not the same factor as I had before, but that's okay. And all I did was here, I took 6x squared minus 2x and I divided out my common factor. We found out the common factor between these 2 terms was an even number of 2 and an x, and that's where I got my 3x minus 1. Okay, so I'm dividing it out. Next, I'm going to take -9x plus 3, and I can see my greatest common factor is 3, right? So I could say that 3 -9x divided by 3 is going to be -3x. Ooh, not so good. And positive 3 divided by positive 3 is a positive 1. So we're close. Okay, I can see I wanted a positive 3x minus 1. If I took out a positive 3, I'm left with -3x plus 1. So we're close. Let's look at this a little bit closer, a little bit more detail. So if I have negative 9x plus 3, I could factor out a negative 3. That means I'm going to take negative 9x and divide it by negative 3. Okay, negative times a negative turns into a positive. 9 divided by 3 is a positive 3, and the x doesn't cancel each other out. Then I'm left with a 3 divided by a negative 3, and that's going to equal to a negative 1, so that's good. So it's almost like I can take this second part and factor it out like this. Now, lucky for us, we see that 3x minus 1 is one of my factors, or a common factor in between those ones. So, just like in our previous questions, 3x minus 1 is our common factor, and according to the distributive property, it was divided or distributed to both the 2x as well as the negative 3. Sorry about that line there. And instead now, I've got the same two factors I did before, just in a different order, and we know that whenever you multiply two things together, it doesn't matter what order they come out to, they should equal to the same thing.